So example 2, this is example 2. Let's consider one message. Okay, m is equal to one message. Okay, na? So some big message. Okay, consider it's a big message. Something you are sending one message here. So is that Chetan to Manoj? Okay, na? So one message here. Chetan is there, sending message to Manoj here. Okay, na? Manoj. Okay. So what you will do, you will going to send a message from here to here. Okay. I don't know. One big message. Maybe Chetan may send, go to hell. He may send like this, go to hell. Go to hell. Like this. I don't know. Really, I don't know. Just I'm writing. That's it. Simply. Just I'm writing this one. Some kind of message like this. Okay. So what is sending Chetan? Chetan is sending a message. He is a sender. Again, he is the receiver. So here, he is the sender and he is the receiver. Okay. Na? In this, please understand, in this, there is a big message. Not a simple message. There is a big message. Okay. Not like this. It's little bit something lengthier message. Very lengthy message. Okay. Na? So that message, I will going to represent as M here. Okay. So this message, M is equal to, please observe here, M is equal to here, M1. I don't know, maybe A. You consider M1 as A. It will going to repeat how many times? 0.9 times. Okay, na? 0.9 times. Again, M2, it will going to repeat 0.95. Okay. Again, M3, it repeats 0.3 times. Okay. M4, it repeats 1.1 times. Yesterday I given that one example and this is fraction example. You can use my lectures anywhere you can use my lectures. That much standard lectures, these are all. That much standard. 0.8. Okay. Now see here. Basically, I told you. So this is the message. Maybe M1 maybe A, M2 maybe B, M3 maybe C, M4 maybe E, M5 maybe something. So they may give message like this: A, B, C, A, B, C, A, like this. So if they have given, you have to count A. How many times? 6 times. A is equal to 6 like that. Understanding? A is equal to 6 like that. Okay, na? So that is what exactly I have taken this one. M1 is equal to 0.9 like that. Nothing else. I'm not doing anything extra. Okay, na? I think you people got this. Why I'm writing this one. Now see here. Let's take this. Okay, I will want to write here saying that M1 is equal to, okay, something like, say here, M1 0.9. Okay, na? M2 something like 0.95. Okay, na? Again M3, see here, M3 something like 0.3. Just I'm taking this one. Okay, it's not 8, it's 0. Okay, M4, that is something like 1.1. Okay, na? M5, you take M5, that is something like what is that? 0.8. Okay, na? So first you write like this. Now please understand, everybody please understand here. Okay, in previous program we have discussed nothing but in previous example. So this is example number 2. In previous example 1, so what we have did, we are taking 2 minimums here, yes or no? we are taking two minimums here. You can able to see we are taking two minimums. Okay. After two minimums, what we will going to do? We will going to add it. Again, we will going to get a new value. Nothing but what we are taking. See here, everybody, please observe here. Everybody, you should observe this one. I will take it here. Bigger one in this way, like this. I will take it. Okay, that's better. So what is that exactly? M1, M1. So that is 0.9. Again M2, 0.95. M3, 0.3. Okay, M4, that is 1.1. Again M5, that is 0.8. These are the values we got it. Nothing but basically what is this? Actually frequency number of times got repeated. Now please here, everybody observe here. Everybody please observe here. In this, everybody observe here. One thing you need to understand right now. One thing you need to understand here about this. So this is a big message. Yes or not? This is a big message. In this big message here, when I take two minimums, fine. See here, everybody observe here. What are the minimums? Two minimums here. One is 0.3, another one is 0.8. These are the two minimums. What we will going to do? We will going to take two minimums. Again, we will going to add it. Again, new value we will going to get it. That one we will going to be inserted into this particular set. Yes or not? Inserted into this particular set. Nothing but array you are taking here. Okay, now that is what exactly we are doing. Nothing but what? Please understand, nothing but what? We are taking two minimum, nothing but deletion we are doing. Yes or not? We are taking two minimum, 0.3, again 0.8, nothing but what? M3 and M5. We are taking two minimum. That is D1 I will going to consider. Again, one more I will going to consider D2. Yes or not? We are popping out from here. Yes or not? We are deleting from here. M3 and M5 we are deleting from here. What we are doing, we are adding. After that, we are taking two minimums. We are finally we will going to get, we are adding these values. Again, if finally we will going to get a new value, that one we are inserting here. This is the process we are doing or not? You tell me. This is the process we are doing or not? You please tell me. This is the process you are doing or not? So two times we are deleting. Please here. That's what? Two times. Two times. Two times we are deleting. That's why what happens? What is the time complexity? You will going to get it 2 log n. 2 log n you will going to get it. Clear everyone? Everyone clear? Two times you are deleting. Please here D1 and D2. Two times you are deleting. Nothing but it takes 2 log n. Again one more. See here, one more important. After adding D1 and D2, see here, after adding D1 and D2, you will going to get a new value, something like T. Yes or not? Something like T. Nothing but the entire process, this entire process, how much time it is taking? Entire process, how much time it is taking? Totally 3 log n. Correct? 3 log n. Correct? Totally how much time it is taking? Totally 3 log n it is taking. Please understand this. This is the process we are following in Huffman coding. Clear? Everybody okay? So this is the process we are following Huffman coding. Let's take one by one. One by one we will finish now. Okay, now one by one we will finish. That's it. So let's take this one, first one. What we're going to do? So we're going to take here. So that is D1. This is D1. Again, one more, that is D2 here. So what are the minimums? 0.3 and 0.8 are the minimums. 0.3 is nothing but what exactly? It is a least minimum. Okay, so that's why 0.3, again 0.8. Clear everyone? 0.3 again 0.8. Okay, so these are the two minimums. When I add this, please here, when I add this, what is the value you will going to get? 8, 9, 10, 11. Nothing but 1.1 you will going to get it. That one you will going to insert here. That one you will going to insert here. What is the new T1 value? T1 is equal to, okay, sorry, T1, what we got it? 1.5. So this is the process you have to follow. Clear? Clear everyone? Everyone okay? Hello, everyone okay? Everyone okay? So nothing but I think you people got this. I think you people got this. Step one, what we have to do? Please observe here. Step one, what we have to do? So identify the two minimums in this particular array. Again, or in the set, okay, in this message, okay, whatever the frequencies you are getting, identify the two minimums in this. Again, add them, whatever the value you are going to get it, that one inserted into this particular one. Okay, that is what exactly you have to do. Again, sir, how to write? Okay, sir, we got this one. Okay, sir, how to write a Huffman code tree? See here everyone. See here everyone. So what is that? Basically, see here, what is that? Minimums are what? One is M3, another one is M5, right? One is M3, another one is M5. See here, now what we're going to do? M3 is nothing but 0.3 or not? M3 is nothing but 0.3 or not? So that's why we have to write it left side. That's why M3, M3, that is 0.3. Okay, na? Again, see here. Again, one more, M5. What is the value? That is 0.8. We got it already. Fine, 0.8. So if you add these two, these are all the two minimums. These are all the two minimums. If you add these two, what is the value you're going to get it? 1.1. 1.1. That value I will going to name it as T1. Clear? Up to here, clear? Everybody, up to here, clear? Up to here, clear? Okay. You got the tree? Fine. This is called it as Huffman code tree. Okay, fine. I think you people got this. Next, come back. Come back to the code. Come back to the process. Let's see. Okay, that is okay, fine, no problem, that is okay. So this one, exactly what I'm telling here. Here, how much time it is consuming here for totally doing all this here, for totally doing all this. Okay, when you add it, what you will going to get it? 1.1. So totally how much time it is taking? Totally 3 log n. See, 3 log n. It's taking 3 log n. That is what I said here. Okay, clear everyone? Like this you have to learn, like this you have to learn, please. Now okay, that is fine, good. Now nice. Next we will going to do some more. Okay, M3 is over. Can I cancel this one? M3 is over. Again, M5 is over. Cancel it. What is left? M1 is left, M2 is left, M4 is left. Again, T1 is also left. Nothing but ends before 1 2 3 4 5 was there. Now how many are there? 1 2 3 4 is there. One person got deleted. One person got deleted. Okay, next one. See here, next one. Everybody observe here, please. Okay, so again D1, again one more D2. Okay, now. So what I will going to do in this, please, in this, everybody, in this, please observe. Please observe which is the minimum in this. Which is the minimum in this? Can I say 0.9? 0.9? 0.9. This is the minimum. Yes or not? This is the minimum. Here you can able to see that is exactly here M3. Again that is M5. Correct? 0.9 is nothing but what exactly that is M1. Okay. Here 0.9 is M1. Okay, that is fine, no problem. Again, compared to the one more lesser, one more minimum. Okay, 0.95. 0.95. What is that? That is M2. Clear? Everybody clear? Please see, everybody clear? Okay, everybody clear? Okay, now if you are clear, if I add these two, what is the value you're going to get it? If I add this two, what is the value you're going to get it? 0.9. I think 1 point something 85 you're going to get it. Okay, 1.85 you will going to get it. Yes or not? So that one I will going to call here. See here, that one I will going to call here T2. What is that? 1.85. Now see here, M1 is over, M2 is over, cancel. Okay, how many left now? So ends before 4. See here, 1, 2, 3 is left. That's it. Yes or not? 1, 2, 3 is left. Over. So this is the process. Now tree, how to write a tree? See here. How to write a tree? Yes or not? You have to write the tree or not? Now that is fine. Okay. That is fine. Okay. No problem. So basically see here. Please observe here. Basically see here. Now there is a no relation. Yes or not? There is no relation. When you do this one, there is no relation. T1 is not, we are not taking T1. Yes or see, observe here. We are taking T1. No, T1 is not in the part. Okay, T1 is not in the picture because M1 and M2 we are taking. See here. M1 and M2 we are taking. See here. M1 and M2 we are taking. T1 is in the picture. No. Now what to do? Now what to do? No, nothing. What do you have to do? Just take it in separate. Okay, take it in separate somewhere here. M1. Wherever you want it, you can take it. No problem. Just I'm taking it. Okay, fine. Again, what is the M1 value? That is 0.9. Okay, na? Again, M2 value, I will take it. M2 value. See here, M2 value. What is the value? 0.95. When I add this, when I add these two minimums, when I add these two minimums, what is the value you are getting? 1.85. Okay, be careful. 1.85. Okay, na? So I don't know which now it is not connected with this particular tree. So later maybe it will connect. Okay, wait for that. Wait for that. So I think this is over. Everything is fine. So this one, what I will going to do? I will going to give the value that is called it as T2. This is I am calling as a T2. Fine. This is fine. Now come back, guys. Now come back, everyone. Come on. This is also over. Okay, this is also over. Everybody got this one. This is also over. Nothing but here. How much time it will going to consume again? See here, how much time it will going to consume again? Same thing. 3 login. Why? Because 2 time deletion, 1 time insertion. 3 login. 2 times means 2 login. 1 time insertion, 3 login. Correct? Everyone are okay? Everyone are okay? So this is the process you have to follow. Now one more time we will go to do one more time. Still we have 3 na, 1 2 3 is there na. So we'll going to identify again minimum. See here in this, please check in this which is the most minimum. 1.1 again 1.1, correct? 1.1 again 1.1. I will change the color. Okay, so that is 1.1, that is T1. Okay, 1.1, that is T1. I will going to consider this one as T1. How much value? 1.1. Okay, na? Again this one. What is that? So this is over. M4. That is M4. Correct? M4. What is the value? Again 1.1. I told you, wherever you want it, you can able to take. If the values are equal, wherever you can, if you want it, you can able to take it. There is no problem with this. After adding this, please here. After adding this, what is the value you will going to get it? You will going to get the value 2.2. Correct? 2.2. That is insertion you will going to do. Correct? I will going to do the insertion. So here I got the 2.2. Okay. So what is that? 2.2. That is T3. T3. Nothing but what happens here? See here, everybody. What happens here? M4 is gone. Again, T1 is gone. Now what is left? T2 is left and T3 is left. Write the tree. Write the tree now. Please, everybody, write the tree. Please. Now you have to write the tree. Basically, observe here. Now, so we were taking T1. Again, you can able to observe here. See, T1 and M4. Please here T1 and M4. Yes or not? Now you can able to see this one. T1 is there. Yes or not? M4, M1 is there. Yes or not? Can I take in the right side? Can I take in the right side? Of course. Why not? So let's take 1.1. That is M4. Okay, now add this two. Please now add this two. Now add this two. Clear? Now add this two. Clear, everybody? So if I add this to what is the value we got it? That is 2.2. 2.2. Clear? What is the name I have given? T3. T3. See here, T3. Fine. So we got here T2, again T3. Now go to the problem. We have T2 also, we have T3 also. Yes or not? Now see here. So again, please see, observe here, again, for this watch. How much time it takes? Same thing again, 3 login. 3 login. Correct? 3 login. One more time we're going to do. One more time. See here, again, same thing. Deletion. D1, deletion, D1, D2. Okay, deletion D1 and D2. Again, we will going to insert one more here. Yes or not? So let's take which is the minimum 1.85. Yes or not? 1.85 is the minimum or not? So I will say 1.85. So that is what is that exactly? That is T2. Again, after that, what is the T3? Okay, what is that value? 2.2. 2.2, correct? 2.2. So when I add these two, what is the value we are getting? That is 4.05 you are getting. Something like 2, 3, okay, 4.05 you are getting. So nothing but what? You will going to get the new value, that is T4. What is that? 4 point, okay, 4.05. Okay, now, so this is the 4.05 you are getting. Again, how much time it takes? Again, 3 login. 3 login. Understood? This thing's over or not? This thing's over or not? Yes or not? Now go back to the tree. See here, everybody, go back to the tree. Now T2 we have, that is 1.85 left side. I told you minimum view we are creating. So that is basically it's a binary tree. Huffman code tree. Now it will become Huffman code tree. So that's why here 1.85 left side is there, 2.2 right side is there. Totally how much you are getting? 4 point how much? 0.5. Clear? Everybody clear? So this is your Huffman code tree. This is your Huffman code tree. Any doubts, please ask me now. Any doubts, please ask me. Any doubts? Okay, again here, again this one more thing I forget. To create this min heap, how much time it will take? N time. To create the min heap, okay, min heap, how much time it will take? N time. N time it will take. This is also important. Okay, totally. What is that? Big O of N. Please, this is also important. Be careful. Now you people tell me, any problem is there? I will going to help you out. I will going to help you out. Please tell me. I will going to help you out. Okay. I think everybody got this one. This is the procedure. Please follow this procedure. This is the best procedure in the world. Okay. Next. Okay, we got the tree. Basically, according to the trees, this is the root. We know that this is the root. Yes or not? We got it. This is the root. We got this. This is the root. Now, what we're going to do, I told you very clearly what we have to do. Maybe in examination, okay. See, normal examination, they will going to ask left side, you have to put 0, right side, you have to put 1. Some of the big examinations like gate examination, something like gate examination, those people, what they will going to do up to here, okay, they will keep quiet. They will say left side, you put 1, right side, you put 0. But actually, what is that? By default, this is by default. Default values you have to use like this. Okay, now this is Huffman encoded tree. We created a Huffman encoded tree. Now you see, please observe. So this is what default you have to give the values. Left side, whatever the things you will going to find left side, put 0, 0, right side 1. Okay, this is right side 1, left side 0, 0. Okay, right side 1, right side 1. Over. That's it. Yes or not? Yes or not? Okay. So this is the code we have created. This, after creating this one, what we will going to call this one? This one we will call it as Huffman encoded tree. This is the one. Okay. Sir, what about codes, sir? What about codes, sir? Nothing. Don't worry. Huffman code. I will going to give now Huffman codes here. Everybody, Huffman code. I will give now. Huffman code. See the Huffman code now. So how are you going to get it? See here. So first one, suppose, see, go back please here. M1. So what is the code you will going to get for this? M2. What is the code you will going to get for this? M3. What is the code you will going to get for this? M4. What is the code you will going to get for this? M5. What is the code you will going to get it? Again, please here. Chetan is sending some message to whom? Manoj. Please understand. Chetan is sending some message to Manoj. Nothing but basically Computer, what language it will going to understand? It will going to understand binary language, right? Yes or not? It will going to understand binary language, right? Nothing but whatever the codes you will going to get for this, it should be in the binary form, right? That's why. See here now. Everybody, see here, observe here. Now see here, I wanted to see everybody observe here. I will take like this M1. Okay now. Fine. M1. Again, I will say M2. Again, M3. M4. Again, let's take M5 also here. Okay. Okay. Now see the codes. What are the codes it will going to generate? Everybody, please careful. Everybody observe it. Now see the codes. What are the codes it will going to generate? Everybody. I want to go to from the root. You have to start from the root. Please start from the root. Start from the root to generate the code from the root to get the Huffman code. Okay. So now I want M1. What is the? I want to go to root to M1. How will go? Left side 0 0. You will going to reach M1 or not? That's what. What is the code? 0 0. That's it. Okay. How many bits? 2 bits. How many bits? 2 bits. Again. This one, I want to go to M2. 0 1. Over na? 0 1. How many bits? Again, 2 bits. Sorry. How many bits? Again, 2 bits. Over. I want to go to M3. See here. I want to go to M3. How? 1 0 0. Yes or not? 1 0 0. Over. Yes or not? How many bits? 3. 3 bits. Again, I want to go to M4. M4. Where is M4? 1 1. That's it. M4. 1 1. Over na. Again, I want to go to M5. Where? How to go? 1 0 1. Yes or not? 1 0 1. Over. You got the encode or not? Huffman encode. Huffman code. You got it or not? See here, everybody. Huffman code. You got it or not? Very simple. That's it. This is the best one. Actually, this is really best. Okay, now fine. Total. You find out the total now. Total. That is equal to, okay, M1 plus M2 plus M3 plus M4 plus M5. Okay, now that's it. Now, what is the M1? 0.9. We know that M1 is what is the value? That is 0.9. Can I write here? Because I have some shortage of space. Can I write here? So M1 is what? That is 0.9. 0.9. See here, everyone. 0.9 into how many bytes it is taking? How many bytes it is taking? 2 bytes. 2 plus. Okay, now M1. M2. What is that? What is the value M2 here? 0.95. 0.95 into. Okay, how many bytes it's taking? 2 bytes again. Correct? 2 bytes again. Fine. Again, M3. Where is M3? 0.3 into M3. here 3 bytes it is taking. Changing or not? See, here also changing, here also, everywhere it will change. Don't worry. Again, M4. Where is M4? M4 is here. So what is the value? 1.1 into, okay, 2 bytes again. Plus. Yes or not? M1, M2, M3, M4 is over. Yes or not? Again, M5. Where is M5? 0.8. 0.8 into, so how many bits? 3 bytes. 3 bits. Fine. If you add, if you do the calculation, what is the value you're going to get it? What is the value you're going to get it? For one character, see here, everybody observe here, for one character, to send the one character, something like M1. See, to send this one character M1, okay, to send this one character M1, how much bits it is taking? 9.2 bits it is taking. 9.2 bits it is taking. Okay, for one character, check it. Okay, for one character. Okay, so what we're going to do? So basically, for one totally for one character, it is taking this much. Again, for one character total, on average, total an average. You see, okay, how much it will take? 9.2. Okay, divide by 4.05. Root value here, root value. Okay, so this much bits it will want to transfer. Bits per character. It will transfer. That's it. That's it. Very simple. That's it. Again, if you are able to understand all these things, okay, if you are able to understand all these things, there is one more important thing. There is one more important thing I wanted to tell you. I will going to write here. If possible, I will going to write here. Where can I write? I can write in new page, please here. 1 minute. So something they will going to give in some other time, they will going to give you code like this: encode, encode, encode message, encode message that is equal to something like this: 101. Okay, again 011. Okay, na? Okay, again 100. Okay, again 011, again 010, 1100. Okay, 1100. Now see here, think like this is a message, encode message. I wanted to decode this, decode message. Here you will going to get it. Suppose that's what I'm telling you. Chetan is having an encode message. If I send this message to this guy, okay, so when it is delivered to Manoj, it will going to be decoded. Where it will going to decode? In the place of Manoj, it will going to be decoded. In the place of Manoj, it will going to be decoded. Now, sir, how to identify these things? What is this exactly? Here is the matter. Here is the matter. You can able to see here. For example, see here. That's what. See, 0 0, what is the value? You can able to see 0 0, what is the value? Basically m1. Okay, basically m1. 0 0, basically m1. You will going to get it. Suppose 1. Okay, you can able to see this one. Please everybody observe here. You can able to see this one. 101. See here, 101. You please observe. Okay, 101. How to go to 101? 1 0 again 1. What is the value? That is, what is the value? 1 0 1. What is the value? M5. Nothing but this code indicates here, whatever the code, this code indicates very clearly. These 3 bits indicates very clearly. Please observe, these 3 bits indicates very clearly. Sorry, these 3 bits indicates very clearly. So this is the message of M5. Correct? Correct or not? This is the message of N5. Okay, now see here, 011 is there. Please observe here, 011 is there. Not only like that, you will going to get in a different way also. Basically, so just you have to go with the code. Just you have to go with the code. Go back here. 0, okay, 0. Again, you can see 11. 0 here, 0 is there. Again, 11. Is there anywhere 11? Is there anywhere 11 like that? M4, you check it, M4, M2, M3. Nothing like that. Okay, so nothing like that. We are not getting. That is what I told you. We are not getting this one. Now you please check it. Everybody, please, you now you check it. 0 1 1, where you will want to get it? 0 1 1, we are not getting anywhere. Okay, leave it. Don't worry. Leave it. Don't worry. No need to worry about that one. Now check another values. Some other values. Wait. Next. Okay, 0 1. Where, anywhere you are getting 0 1. Check here. 0 1. Where you are getting M2. 0 1. M2 you are getting. Write it. Next. 0 1. That is M2. This is M2 message. Clear, everyone? Everyone okay? Everyone okay? For 2 bits. Basically, you can able to observe here. M2, what is that? 0 1. Yes or not? 0 1. So that is how you have to check the each and every code. Please understand, you have to check the each and every code. Automatically you will going to get it. All this series. Automatically you will going to get all this series. That is what? 101. You please check it. 1. Anywhere 1 is there? 1. Am I meeting anywhere? No, nowhere I am meeting. Okay. So this is what we have to get it. 101. So 101. I am meeting me M3. So that's why this code is belongs to these 3 bits. These 3 bits are belongs to M5. So this is belongs to M2 like that. Understood? Understood? Everybody understood? Understood? Again here 1 1 1 1. What is that? See here 1 1. We have 1 1 1 1. What is that? M4. Like that you have to follow. So you will going to get a message here. Okay, encoded message you will going to be delivered here. So automatically what we can able to do, we can able to see the same message. This is the method we will going to use the Huffman coding. Now please tell me you have any problem in this. Please tell me you have any problem in this. Maybe not it.